In this video, we are going to study partial derivative of first order. If we are given a function z of two independent variables x and y, then we are going to study how to find partial derivative of z with respect to x and partial derivative of z with respect to y. And u is another function of three independent variables x, y and z. We are going to study how to find dou u by dou x or partial derivative of u with respect to y and partial derivative of u with respect to z. The order of each of these differentials is 1, hence they are known as partial derivatives of first order. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Let us find partial derivatives of first order of the function log x sin y. Let this function be z. Here z is product of two functions. For dou z by dou x, we have to use product rule of differentiation, which is first function log x into derivative of second d by dx of sin y plus second function sin y into derivative of first function d by dx of log x. This is log x into, since this is partial differentiation with respect to x, we have to treat function of y sin y to be constant, and derivative of constant function is 0 plus sin y into derivative of log x is 1 upon x. So dou z by dou x will be sin y upon x, and dou z by dou y will be, again by product rule, first function log x into d by dy of sin y plus second function sin y into d by dy of log x. This is log x into derivative of sin y with respect to y cos y plus sin y into derivative of log x with respect to y. But for partial derivative with respect to y, we have to treat a function in x to be constant, and derivative of constant is 0. So dou z by dou y log x cos y. Next we find partial derivative of z equals sin x upon cos y. So dou z by dou x will be by quotient rule of derivatives upon cos square y in the numerator cos y into d by dx of sin x minus sin x into d by dx of cos y. This is cos y into d by dx of sin x cos x minus sin x into d by dx of cos y is 0 because cos y is to be treated as constant. So its derivative is 0 upon cos square y. This is cos x cos y upon cos square y. Cancelling cos y with 1 cos y, dou z by dou x will be cos x upon cos y. Next we find dou z by dou y, which is upon cos square y in the numerator cos y into d by dy of sin x minus sin x into d by dy of cos y. This is cos y d by dy of sin x is 0 because sin x is constant minus sin x d by dy of cos y minus sin y upon cos square y. This is sin x sin y upon cos square y. So dou z by dou y is sin x sin y upon cos square y. Partial derivative of z equals tan raised to x cos y. First dou z by dou x by product rule tan raised to x d by dx of cos y plus cos y d by dx of tan raised to x d by dx of cos y is 0 because cos y is constant plus cos y into d by dx of tan raised to x is tan raised to x log 10. So dou z by dou x is log 10 tan raised to x cos y. Next, dou z by dou y will be tan raised to x d by dy of cos y plus cos y into d by dy of tan raised to x. Tan raised to x d by dy of cos y is minus sin y plus cos y into d by dy of tan raised to x is 0 because tan raised to x is to be treated as constant. So dou z by dou y will be minus tan raised to x sin y. To find partial derivative of z equals x upon x square plus y square. First, dou z by dou x by quotient rule of derivatives x square plus y square whole square, numerator x square plus y square into d by dx of x minus x into d by dx of x square plus y square. X square plus y square d by dx of x is 1 minus x d by dx of x square plus y square. First, d by dx of x square 2x plus d by dx of y square will be 0 because it is partial derivative with respect to x. So, function of y is to be treated as constant upon x square plus y square whole square. X square plus y square minus 2x square upon x square plus y square whole square. This is y square minus x square upon x square plus y square whole square. So this is dou z by dou x. Next we find dou z by dou y, which is upon x square plus y square whole square. In the numerator x square plus y square into d by dy of x minus x into d by dy of x square plus y square. X square plus y square d by dy of x is 0 because x is constant minus x into d by dy of x square plus y square. First, d by dy of x square is 0 because x square is constant plus d by dy of y square 2y upon x square plus y square whole square minus 2xy upon x square plus y square whole square. This is dou z by dou y. How to find partial derivative of z equals sine inverse x upon y. So dou z by dou x will be 1 upon under root 1 minus x square upon y square into d by dx of x upon y, treating 1 upon y as constant. So that will be 1 upon under root y square minus x square upon y square into treating 1 upon y as constant. Derivative of x is 1. This will be square root of y square is y, that goes up here, upon square root of y square minus x square into 1 upon y. This y cancels and we get dou z upon dou x equals 1 upon square root y square minus x square. Next we find dou z by dou y, which is 1 upon square root 1 minus x square upon y square into d by dy of x upon y, treating this x as constant. So this is 1 upon under root y square minus x square upon y square into x is constant and derivative of 1 upon y with respect to y is minus 1 upon y square. So this will be y that goes up here upon square root of y square minus x square into minus x upon y square. So dou z by dou y will be cancelling this y with 1y of y square minus x upon square root of y square minus x square. How to partially differentiate z equals tan inverse x upon y. Dou z by dou x will be derivative of tan inverse x upon y is 1 upon 1 plus x square upon y square into d by dx of x upon y, treating 1 upon y to be constant. So this will be 1 upon x square plus y square upon y square into constant 1 upon y, derivative of x with respect to x 1. This will be y square upon x square plus y square into 1 upon y, cancelling this y from 1y of y square. Dou z by dou x will be y upon x square plus y square. Next we find dou z by dou y, which is derivative of tan inverse x upon y is 1 upon 1 plus x square upon y square into d by dy of x upon y, treating this x as constant. So this will be y square upon x square plus y square into constant x, and derivative of 1 upon y with respect to y is minus 1 upon y square. Cancelling this y square with this y square, we get dou z by dou y as minus x upon x square plus y square. Find partial derivative of z equals x raised to y. Dou z by dou x will be y x raised to y minus 1, where this y is constant, and dou z by dou y is x raised to y into log x, because here this x is constant. If u is a function of x and y, and v also another function g of x and y, then we have following rules of finding partial derivatives. First, if z is u plus minus v, then dou z by dou x is dou u by dou x plus minus dou v by dou x, and dou z by dou y is dou u by dou y plus minus dou v by dou y. Number 2, if z equals u into v, then dou z by dou x will be u into dou v by dou x plus v into dou u by dou x, and dou z by dou y will be u into dou v by dou y plus v into dou u by dou y. And finally, third, if z is u upon v, then dou z by dou x will be upon v square, in the numerator v into du by dx minus u into dv by dx, and dou z by dou y will be upon v square, in the numerator v into dou u by dou y minus u into dou v by dou y. Now we will see how to find partial derivatives using these standard rules. If z equals ax square plus by square plus 2abxy, we have to find partial z by partial x, partial z by partial y. First, let us name ax square as u, by square as v, and 2abxy as w. So we have z equals u plus v plus w. Now dou z by dou x will be dou u by dou x plus dou v by dou x plus dou w by dou x. So dou by dou x of ax square plus dou by dou x of by square plus dou by dou x of 2abxy. This is ax plus this is with respect to x. So by square to be treated as constant, and derivative of constant is 0. So this is 0 plus 2ab, which is constant, dou by dou x of xy. So dou z by dou x will be this 2ax plus this 2ab. Now dou by dou x of xy will be x into dou y by dou x plus y into dou by dou x of x is 1. This is 2ax plus 2ab. Partial differentiation of y with respect to x will be 0. So 0 plus y is y. So 2ax plus 2aby is dou z by dou x. We have found dou z by dou x equals 2ax plus 2aby. Now we will find dou z by dou y directly equals dou by dou y of ax square plus dou by dou y of by square plus dou by dou y of 2abxy. This is dou by dou y of ax square will be 0, because we have to find partial derivative with respect to y. So ax square should be treated constant, plus dou by dou y of by square will be p into derivative of y square with respect to y, 2y, plus dou by dou y of 2abxy will be 2ab, and for xy we use product rule. So first function x into derivative of y with respect to y is 1 plus y into derivative of x with respect to y will be 0 because here x is to be treated as constant. So this is 2by plus 2abx. So this is dou z by dou y. If z into x plus y equals x minus y, we have to find dou z by dou x minus dou z by dou y whole square. From this given statement, we get z equals x minus y upon x plus y. For finding value of this, we need dou z by dou x and we need dou z by dou y. So first let us find dou z by dou x, which is we have to use quotient rule of differentiation. So first upon x plus y whole square, in the numerator x plus y into dou by dou x of x minus y minus x minus y dou by dou x of x plus y. This is x plus y into dou by dou x of x minus y is 1 minus 0 minus x minus y dou by dou x of x plus y is 1. So dou z by dou x is x minus x will be 0 and y plus y will be 2y upon x plus y whole square. We write it here. Next we find dou z by dou y, which is upon x plus y whole square, x plus y into dou by dou y of x minus y minus x minus y dou by dou y of x plus y. This is x plus y dou by dou y of x minus y will be minus 1 minus x minus y dou by dou y of x plus y is 1 upon x plus y whole square. This is minus x minus y minus x plus y upon x plus y whole square, which is y minus y 0 minus 2x upon x plus y whole square. This is dou z by dou y. We write it here. Now we find this dou z by dou x is 2y upon x plus y whole square minus dou z by dou y, which is minus 2x. So that will be plus 2x upon x plus y whole square. And this whole square, this is 2y plus 2x is 2 times x plus y upon x plus y whole square, and this whole square 1x plus y cancels with 1x plus y of x plus y whole square, and what we get is 2 square 4 upon x plus y whole square. So this is the required value, 4 upon x plus y whole square. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.